when it comes to simplifying our exponents, we just have to remember our basic rules in terms of exponents. The major rule is that to simplify most exponents, we've got to use a common base. So there's times if I have m and n, or if I have x to the nth. If I have something like this going on where I have the same base of x and I'm multiplying two things together, what I can then say is that this is the same as m plus n. For example, 2 to the first times 2 to the 8th power, I could say, since I have the same base, these are just equal to 2 to the 9th power. Basic multiplication rules. If we look over at the other one where I'm dividing, we could really do it the same way. If I have a base to the m, same base to the nth, I could say that these are actually equal to m minus n. So, very similar explanation, or very similar example. If I have 2 to the 8th divided by 2 squared, I have the same base of 2. 8 minus 2 is 6. Boom. That's all I got to do. That's a simple way to simplify our exponents there. Two other rules that we're going to use. One of them has to do with taking a power to a power. So if I have x to the m power being raised to the nth power, I can say really I have x to the m times n power. Example of that. 2 to the 4th to the 3rd power. I actually have 2 to the 12th power. So that's another pretty simple one. And the last one is if I am working with a negative exponent. I could say that's the same as 1 over x to the m power. So our example would be 2 to the negative 3rd power. That's the same as saying I have 1 over 2 to the 3rd power. So just a couple simple rules there when it comes to simplifying our exponents. It makes our life a little bit easier for when we run into problems that look a little bit like this. So to simplify these, if I look at the first one, 3n squared over 3n squared to the 2nd power. What I got to do first is this squared. Got to treat it kind of like distribution. So I have to distribute that twice. So my numerator I'm going to keep the same. On the denominator, I'm going to have 3 squared. And then I'm going to have n squared that's being squared. So I'll have 3n squared on top over 3 squared is 9. N squared to the 2nd power is going to be n to the 4th power. Now if I look at it, 3 and 9 I can simplify down to 1 and 3. If I have n squared and n to the 4th, they have the same base. I can subtract since I'm dividing. So n squared divided by n to the 4th, I can subtract that and I get n to the negative 2nd, because that's what 2 minus 4 is. And then, from the basic rules I just learned, if I have a negative exponent, I can put that in the denominator. I could say that this whole thing is equal to 1 over 3n squared. So I simplified that just using my basic rules. If I look at my next problem, which is 3k times 2k to the 3rd, all to the 3rd power. I'm going to start this one differently. I'm going to do whatever's in the parentheses first. So I've got 3k times 2k to the 3rd to the 3rd power. I'm going to look at these k's first and I'm going to combine them. So obviously 3 times 2 gives me 6. K to the 1st power times k to the 3rd power gives me k to the 4th power. All I do is add up my exponents. So 1 plus 3 gives me 4. Got this whole thing being raised to the 3rd power. So now I can distribute that 3. So I have 6 to the 3rd times k to the 4th to the 3rd power. Now if I look at that, 6 to the third power is going to give me 216. K to the fourth to the third power gives me K to the 12th. And since my exponent is positive, that's as simplified as it needs to get. And my final example. This one looks like a mess, but it's really not that bad. First thing I'm going to do, I'm going to distribute all of my powers to a power. So I'm going to distribute my -2 here. I'm going to distribute my 3 here. So if I distribute those, I'm going to have x, 0 times -2 is still 0. Y squared times -2 gives me y to the -4th. Then I have that times y to the -4th to the third power gives me y to the -12th. All over x to the -1st, y to the -4th. So x to the 0 power is just going to be a 1. I can cancel that one out. Don't need to write it anymore. I've got y to the -4th times y to the -12th. Remember, if I have the same base, which I have, I can just combine my exponents. So I've got y to the -16th over x to the -1, y to the -4. Now I've got my y's in here. Got the same base, so I can subtract. -16 minus -4 is going to give me a y to the -12 divided by, I still have x to the -1st power. Now my last step. Since both of these exponents are negative, really all I can do is swap where they're at, so flip my entire fraction and just make the exponents positive. So that's going to lead to what I have here, which is going to be x to the +1 over y to the +12. So flipping those exponents is how I get rid of that negative. And then this is as simplified as it needs to be. So all we did was follow our basic exponent rules. If we have similar bases, we can combine, condense, and eventually make things much simpler on ourselves.